Hello, my name is Matthias. My family and I went on a vacation in Europe when I was in grade 5. We went to Germany and took a maglev train around. I was so fascinated by how the maglev train levitated, I decided to do my science fair project that year on it. But I always felt like I could have done a better job at building it and designing it and actually researching the topic. So this year I wanted to revisit it. My maglev train, I tried, but it did not work out. I will talk about it later in the talking section, but yeah. Maglev trains use electromagnets to levitate. To propel a maglev train, you pump flowing electric currents through the track. Maglev trains have wheels that are used for when the train is either stationary or under a certain speed. This is because you don't always want to have the magnets on, and so the wheels are there. So as it gains speed using the wheels, the magnets are fired up and it starts levitating. Maglev trains are much more efficient than regular trains because they have no ground friction and only air resistance. This allows them to reach way higher speeds with much more efficiency, much more efficient. Magnets have polar ends on either side, and so a positive and a negative attract, a positive and a positive repel, and a negative repel. My hypothesis was, as I add more weight to the maglev train, it will drop down until it touches the track. This is because the magnetic field is not strong enough to repel the weight of the train. I think that around the 15-pound mark, it will touch the track. I believed this because the magnets that I got are rated for 20 pounds, and the train will weigh around 5 pounds. So when I added the weight, I measured it in cups of water so we could put it in bags. We measured them in cups of water, and 1 cup of water weighs 0.59 pounds. So we measured it in that. When I added 1 cup of water, nothing happened. When I added 2 cups of water, nothing happened. But the 3rd cup, everything fell apart and the train fell off the track. Luckily, the water did not spill. This has happened because the magnets were trying to repel each other so much that they were pushing, and then they got sucked in like that. So, up here, I first started with metal borders on the track, but then we realized that they weren't polarized, which means they can't have they can't have the same polar end, so they can only attract. So then we had to move to this design, but that one didn't work. It kept falling and it was not a good design. This is because, if you can see here, the magnet is hovering perfectly over it. But as soon as you go over here, you can get like this, and it gets sucked in. And it ends up breaking because it goes like up and then down.